Hello everyone, my name is Tuan Nguyen, and I am a senior student at Swarthmore College studying mathematics and computer science. Today I would like to present my work on extracting data for relevance ranking at Salesforce. Suppose you're searching for the term change password. This query gets tokenized or broken down into two tokens, change and password, which each term we can compute a TF-IDF score with respect to certain fields of the document. TF-IDF is a measure that reflects how important a word is to a document in a collection or corpus. With this simple example, the search term change password would generate a 2x3 table of TF-IDF scores for a document with 3 fields. In reality, the number of fields are much higher, and the length of the search term is much more variable, which determines the number of rows in the TF-IDF table. These TF-IDF scores are fed into a ranking function which produces a score. Documents with the highest score will be displayed on the first of the list, second highest to be the second on the list, and so on. The aim of the search relevance is to tune certain coefficients inside the ranking function so that relevant results are displayed at the top. Initially, all data about TF-IDF scores of each search query was stored in a JSON format, which is a nested tree with arbitrary depth. I wrote a function with mutually recursive call to crawl this tree and extract all the data back into a tabular format. With this data, we can now ask certain questions about how the TF-IDF scores are influencing what user clicked on, which in turn provide us with insights on how to tune the ranking function. Since the scores are organized in terms of different fields, an important question is to decide which field influences user to click on a document the most. As I mentioned before, the size of the table varies by the query length, and in order to train traditional machine learning models on this data, we need to find a way to standardize it. One such way is to sum the data across all tokens. Coming back to the earlier question, I attempt to answer this through a feature importance plot, which could be derived from tree-based model such as random forest. In this case, I use XGBoost or gradient boosted tree. This is what the data look like for training. I chose XGBoost for the following reasons. These season trees are much better for interpretation and visualization compared to black box method. The season tree, such as XGBoost, provides a quantitative framework to measure the contribution of each feature to the final prediction of the click. XGBoost is fast and scalable, as well as robust to outliers. This is my final result, and it shows that fields like title, body, and URL of a document or summary of the document are the most important, which make intuitive sense since they contain the most information about this document. Now that we have this data, we can ask even more fine-grained questions to come up with more insights to tune the ranking function. I would like to thank the following people for helping me with this summer project at Salesforce.